Hello, everyone, and welcome to part 5 of our Introduction to Risk Assessment. This is GCU from the University of Minnesota. And today, we will focus on step 4 of the risk assessment process, risk characterization. Now, we've reached step 4, risk characterization. This step brings together all the information we've gathered from hazard identification, dose response, and exposure assessment to estimate the nature and magnitude of health risk. At its core, risk characterization involves understanding both the toxicological effects of a substance and the exposure levels in the population. We do this by first establishing a health benchmark, such as a reference dose from IRIS data, and then comparing the actual exposure concentration to see if it exceeds that benchmark. For those that are not familiar with IRIS, it stands for the Integrated Risk Information System, an EPA database that provides toxicity values like reference doses and slope factors. These values are widely used as benchmarks for risk assessment. This helps us calculate the probability of a health effect occurring under real-world conditions. The Venn diagram at the bottom is a simple but powerful reminder. Risk exists at the intersection of both hazard and exposure. Without one or the other, risk does not occur. Let's take a moment to talk about risk estimation. This part of the process helps us understand how much risk a certain chemical or stressor might pose to a specific group, whether that's a human population, animals, plants, or even entire ecosystems. First, we look at the estimated or measured exposure level for each stressor and for each population or community we're concerned about. Then we pair that with the available data on the expected health or environmental effects at that exposure level. Together, these two pieces help us estimate what kind of impact a given exposure might have on a specific group in the real world. Now let's look at risk description. This part helps us make sense of the risk assessment results by asking important questions. We consider whether harmful effects are likely to happen to the organisms or populations we care about, such as plants, animals, or even ourselves. We also look at any useful qualitative comparisons, how the results stack up against known benchmarks or similar cases. And finally, we take uncertainties into account, like missing data or natural variability, to understand how confident we can be in our conclusions. Now, let's explore how we interpret risk and communicate our findings. On the left, we have metrics used for non-carcinogenic risks. The hazard quotient, or HQ, is calculated by dividing the estimated dose by the reference dose. For more context, the reference dose is the level established by agencies like EPA that represents the maximum daily exposure expected to be without appreciable health risk. By comparing our estimated dose to this benchmark, the hazard quotient tells us whether a potential risk might exist. If HQ is greater than 1, it suggests a potential health concern. We also use the margin of exposure, or MOE. This is the ratio of the point of departure, often a benchmark dose, to the actual exposure. A higher MOE usually means lower concern. On the right, we look at cancer risk estimates. These are based on lifetime average daily dose, LADD, multiplied by the cancer slope factor. We compare the result to an acceptable risk range. A risk of 1 in a million, or 10 to the minus 6th, is considered negligible. A risk of 1 in 10,000 is borderline acceptable, and a risk of 1 in 1,000 is considered high and may need action. This step helps us understand and communicate whether the risks are acceptable or whether further controls are needed. Step 5 is risk management. This step answers the question, how can we use risk assessment information to reduce or eliminate the risk? One example is that manufacturers might reformulate their products. For instance, after identifying concerns with PFAS, some companies moved to PFAS-free fire retardants as a safer alternative. Another powerful strategy is sharing information. When environmental agencies or the media release information about a chemical or product risk, it can prompt public awareness and pressure for action. This step focuses on making real-world changes based on what we've learned from the assessment. We will dive deeper into this topic in Module 4.
This lesson has been created by the Interdisciplinary Training, Education, and Research Activities for Assessing and Controlling Contaminants from Emerging Technologies Program, a collaboration of the University of Minnesota School of Public Health, the University of Iowa College of Public Health, and the University of California, Los Angeles Fielding School of Public Health. Funding for InTERACCT is provided by the National Institute of Environmental Health Sciences of the National Institutes of Health. The content of this lesson is the sole responsibility of the developers and does not necessarily represent the official views of the National Institutes of Health.